Hey guys, welcome back to this channel. Today we're going to be looking at some questions on fluid mechanics. So basically this is not our usual questions, usual type of questions we usually treat on the channel. But basically we are going to be looking at some question of fluid mechanics, and this particular question is question on hydrostatic law, basically hydrostatic law. So I'm going to revise what hydrostatic law. Hydrostatic law states that the rate of increase in pressure in a vertically downward direction is equal to the weight density or the specific weight. Basically, what I'm trying to say is that the pressure is actually related to density, the height of the column or the height where the fluid is coming from, and the acceleration due to gravity. So I'm going to write what hydrostatic law is actually talking about. Hydrostatic law is talking about that the pressure of a fluid is related to the density, the acceleration due to gravity, and the height of the fluid. So this is basically what hydrostatic law is actually talking about. So basically this question is concerning a body immersed in a fluid inclined at an angle to the surface of the fluid. They are asking us to calculate the force acting as that inclined body. Now they said calculate the force acting at one point of a rectangular lamina 1 meter wide and 4 meter deep, immersed in an oil of specific gravity. Now basically this is not water. Water has specific gravity of 10 raised to power 3. So but now they said it is immersed in an oil of specific gravity of 0.9. So basically this is not water. So let's get going, then we'll know how to solve. Now this, and they said each shorter side to the surface and its length inclined at an angle 60 degrees. So basically let's represent this in a more diagrammatic expression so that we can easily understand it. So we successfully represented this on more understanding diagrammatic expression. So if you can look at the revised equation again, it said each short side is to the surface. Like each short side is to the surface, meaning that the shorter side of the rectangular lamina is actually touching the surface. And there are some questions that they can give you and say that the shorter side should not be able to touch the surface, but it is at also a depth in the liquid. But if you look at this particular question, they said this is the shorter side of the lamina and this is the longer side. So they said the shorter side is touching the surface of the fluid. So basically this is the front view and this is the plan of this rectangular lamina. This is the plan of this rectangular lamina and this is the front view of this rectangular lamina. So the shorter side is actually touching the surface inclined at an angle 60 degrees. So this is the diagrammatic expression. So if the hydrostatic law says that now when this particular rectangular lamina is immersed or inclined at an angle in a liquid inclined at a particular angle, the depth should be from the center of gravity. Now if I can trace this from the plan to this particular point, which is the front view, and also to the surface of the liquid, I will get the depth of my rectangular lamina. So basically we are asked to find the pressure, right? So now we know that total pressure is equal. We have to find the force. We know that pressure is equal to density times gravity times the height of the particular column. But my the pressure acting at a point in a particular liquid is equal to, I call it my F, my force. My force is equal to W times A times X. Now this particular formula means my weight density times the area of the body in which the pressure is acting on times the depth, times the depth. So what is the depth? The depth, the distance of that body from the surface of the liquid it is immersed in. So basically this is the force, or we call it total pressure, or basically this is the force acting on this particular body inclined at a particular angle. Is that taken? So basically, this is the formula we're going to be making use of now to solve the force acting at it at this particular body. So now, let's solve. Now, if looking at this particular depth of the liquid, from here to here, since it's acting at the center of gravity, so basically half of this is what? Half of this can be, I can call it 2 meters, right? Now, tracing it up here to here is also what? 2 meters. So now, to get my depth, I can make use of my trigonometric function. If I can draw it out, drawing it out, I have something like this. Right? Then this is angle 60 degree, and this is my 2 meters, and this is my depth. So basically, to get my depth, I can basically use trigonometric function and say my depth by x is equal to 2 sine 60. Is that understood? My depth is equal to, this is my opposite and this is my hypotenuse. So my depth is equal to what? 2 sine 60. So 2 sine 60 can give us 1.73 meters. So now we have gotten our depth. Remember, we need this formula. This is the formula we're making use of. So we need the area of the body in which the pressure is acting on. So the body of the body, which is our rectangular lamina, to calculate the area of my rectangular lamina, we know that area is equal to what? Length times breadth, right? So the length of my rectangular lamina, which is 4, times the breadth, which is 1, is equals to 4 meters square. Now all that is left is my weight density. My weight density, which is W, is equal to weight over volume, right? Is the formula for weight density. Now, what's the formula for weight? Weight, which is mass times my gravitational constant divided by my volume, right? Then we know that mass over volume is what? Density, right? So I can basically write this as density times G. So my weight density will equal to the density. Remember, they gave us my specific gravity, right? So now, to calculate my density, because I need my density, I already know my gravitational constant. You know that specific gravity is equal to density of the liquid you are looking for divided by the density of water. So basically, I'm looking for the density of oil, right? So I know the density of water, which is what? 10 raised to the power 3, right? Let's call this density of oil divided by 10 raised to the power 3, right? Then the specific gravity given to me was what? 0.9. So basically, density of my oil is equal to 0.9 times 10 raised to the power 3. So I've gotten that. So going back to my weight density, I have 0.9 times 10 raised to the power 3 times 9.81. So basically, my weight density, this gives me my weight density, this gives me 8829. This gives me 8829. So now I can basically write Newton per meter cube. So now I have gotten all my parameters. It's just for me to substitute back to my formula, which says my F is equal to my weight density times my area times the depth. So my weight density, which is equal to what? 8829 times my area, which is equal to what? 4 times my depth, which is equal to 1.73, right? So this gives me 61096.6 0.68 Newton. Converting it to kilonewton, we have 61.09 kilonewton. So this is the force acting on the rectangular lamina at an angle to the surface of an oil of specific gravity 0.9. Thank you guys for watching. Please and please subscribe.